So in the next 40 minutes, this is basically just before you leave for the rest of the day. So I will try to not bore you and try to show you something of interest, which is very interesting for me. So I hope I will be able to make it interesting to you as well. And maybe at the end of this talk, you will be interested to look into your code or whatever you're doing, and with a slightly different eye. That's my hope. So I'm here to talk to you about vulnerabilities in open source libraries. This is not about saying anything negative about open source libraries, but just stating a fact. And the fact is that you have to make sure that your dependencies are up to date. Whenever you're coding in Python, Java, Node.js, any language you're coding, you will always use external libraries. And you want to be sure that those libraries are up to date. And we're going to see the reason why during this speech. So for me, I'm a developer by trade. I started in 1988 in C, an assembler, and then I used a lot of languages. I became a Java champion at a point in 2005, and I started a Java user group, and I'm trying to run my startup called Materian. Is the one that is one of the tools that you can use to manage this problem that I'm going to talk about. And it's important to me that if you like this talk, you tweet. So if you don't like it, it's okay to not tweet. But if you do like it, that would be great for me if you can tweet about it, if you like what I'm saying. Right. What we're going to look at today is we're gonna look at first 3 cases of exploits which are very, very famous. I will use some paper here because my memory is not the one I had when I was young. So, but 3 big exploits that made history. And then we're gonna have a look at the reason why we use open source libraries, so why we're actually doing that. And then we're going to have a look into what is a vulnerability exactly. I mean, at least in the domain of this speech. And after that, we're going to show you a sample of an exploit of vulnerability, which I have all the code for. So, and it's on GitHub, it's public, so you can download it and, well, don't do anything with it. If you can. It's pretty effective. So, take a look at it from the imaginary point of view to learn, but don't use it. Otherwise, I'm probably gonna get in trouble. We're gonna see at some preventive measures and some common delusions, because when I'm talking to people, I always receive from them some mantra, so that they think they are secure, but in reality, unfortunately, they are not. But they think they are. They're very good. They're very talkative about that. Oh, we do this and we do that, and for that reason, we are completely secure. No, you're not. So we're gonna talk through that, because those are the same things that sometimes people tell me. Then 5 minutes for QA and some conclusions. Right now, first one. This is an exploit that happened on the November 2016. Is the San Francisco Metro Transport Agency. So basically, all the metropolitan transport from San Francisco. What happened? They were hacked, and the visitors were welcomed by this screen, which says, "Oops, we just encrypted all the data on your disks, and if you want them back, you have to pay." And that was amazing. So that goes because people went free on rides for a weekend. So this was fantastic for the people. Not really for the company, because they had to pay a lot of money to the ransom guys to get their data back and to have their disk unencrypted. And basically 2,112 systems were impacted. That was a very effective attack. And the problem, the exploit, was based on a deserialization problem on the Apache collection library, who is using that? Nobody? Come on, you can say it. Don't be shy, you can say that. No, it's okay. I use Apache library for a while, I know. They're good. to a point. But I don't like some things that they do, but they're very useful. They do a lot of useful things, so it's okay to use them. But this problem with Apache Collection was so big that Google launched the Operation Rosebud. So basically, they pick up 50 Google engineers, and what they did for a month, I think, for a couple of months, they just fixed this vulnerability in all the open source projects that they were able to find. So it was a volunteer action by Google. First, they fixed their ones, because they were using also Apache. I mean, they're using Guava, okay, but they're also using Apache. And, and they went around and they fixed, for 1 month, 50 people. They did, I don't know how many PRs. This is history, so you can read it. It's brilliant. So good, nice action for Google to say, OK, we're going to handle that. That was very good. And the pretty thing about this is that the vulnerability, you notice the number at the top, CVE 2015-4852. The first number is the year where the vulnerability was disclosed, okay? And the attack, you can see, happened 1 year later, in 2016. So this vulnerability was already public, was in a public database of vulnerability. The CVE is a public database. You can Google just that, and you find the database. There are the links at the end of the presentation. But in 1 year, the guys didn't care to fix it. So 1 year with vulnerable code, and of course, you know, a lot of hackers, they want to get free money. They just exploited it. It's as simple as that. OK, next one. Next one is the Canada Revenue Agency. It's like the HMRC for London, so the central tax agency of the government. It was hacked. Oops. It was hacked, and well, whatever happened, it was never disclosed. So what happened is that at some point, the hack was made public. So the CRA admitted, oh, we have been hacked, but easy, nothing happened. No, trust us, nothing happened. That's what they said. And as today, whatever happened was never disclosed. So the good thing about, you have been hearing of GDPR, now, which is a new compliance law in Europe about privacy. The good thing about GDPR, if something like that happens, if the company do not disclose that, they will be fined big time. Like 10% of the global, no, sorry, 4% of the global revenue, or 10 million euros, whatever the higher. So if they were in Europe and GDPR was in act, they would have been fined big time if they didn't disclose the impact of it. Well, they didn't. They say nothing happened. Okay. Basically, this was, who is using Struts 2 here? Ah, come on. That's good. That's good. Struts 2 is amazing. He has 3 or 4 vulnerabilities that are so good. And the one that was used here was basically a flow in the parser, so that you can send a file via HTTP, and the file can contain MIME type, so you can send what is called? A multi-part inside with MIME separation, and there is a flow in the multi-part parser in Struts 2 that can cause remote execution. And that's exactly what happened. And what you can use as an excuse for these guys is that actually the vulnerability was a 0-day vulnerability. So it was basically discovered by this attack. So this attack is the one that caused the vulnerability to be public. Okay? So that good excuse. This guy, instead, they don't have any excuse. This is the same vulnerability that happened to the Metropolitan Transport Agency. No? No excuses. Sorry, to the CRA. No excuses. The same vulnerability that we saw before, like months later, 3 months later, I think. And this was incredible. So Equifax is the company that manages the credit history of people. So you obtain a loan, get a credit card, or get a bank account. you have a credit score. You exist as a score in a company database. And this is important because based on your score, you can get more credit or not. And this company was managing this for 143 million of US citizens and 44 million of UK citizens. This was hacked using the same vulnerability of the CRA, the same one, 3 months later. And also the guys were smart guys. The CEO, CFO, I don't remember, I think some C-level, I don't remember which ones, started selling their shares before they admitted that they were hacked. No? That didn't sit well with the government. They really didn't like it. But apart from that, what happens when people steal your data from this kind of company? They can do amazing things. A friend of mine, Filippo, had loans started in his behalf. No? And he knew that only because he was contacted by another credit rating company that asked him, "Are you buying a house in Philadelphia?" No. "Well, why did you request a loan?" "Well, I didn't." No? And this is amazing. When those data goes out, there's a massive impact. 143 million is probably a quarter of the population of the USA, or half, I don't know, something like that. This big, no? And yeah, the funny thing is that was very public. Like 3 months ago, they had the same problem. They didn't care to fix it. Now, looking at this, somebody may ask, well, why the hell are we using open source libraries if they're so faulty? Are we crazy? Shouldn't we not use them or do something else? No? I mean, why? It's a good question. Who wrote a logging library in the past? Hey, we have some. Yeah, that's kind of, I did it really. And it's not, unless you're in a very specific domain for a very specific problem, well, you should not do it. Because there are already 1 million logging libraries available, well, at least 4 or 5. I mean, we keep creating new logging library. I'm expecting the blockchain machine learning logging library next. I don't know, something like that. But the thing is, there are a lot of logging libraries available, and they're all very good. Well, not all of them, but some of them are very good. So we shouldn't reinvent the wheel, which also exposes us to a whole new set of security problems. The good thing about open source libraries is that, they're already being tested by a lot of people. And, usually the vulnerabilities are discovered and fixed, no? Also, that allows you to deliver code much, much faster because you don't have to rewrite everything. And, again, login, serialization from JSON to XML, communication via common protocols, all these things, they're already done. Web frameworks. Who's using Spring Boot? Who's using Spring? Only Spring? Yeah. Why do you want to rewrite all that thing? I mean, it's already written. Why do you want to rewrite it? It gives you a competitive advantage. It gives you edge against your competitor. You write things faster. No? And example, you want a state-of-the-art algorithm. So why would you rewrite an encryption algorithm? Are you crazy? I mean, I wouldn't be able to do it. I mean, maybe some of you would be able to do it, but there are already libraries that do that specifically. There's no need to do that. No? And more example like that. But basically what happens now, these days, is around 80% of the code in your project is coming from open source library. And the thing about that is that, the thing you have to consider is that not always, so you get not always the code that you ask directly, but also the dependencies of that code. So for example, Spring Boot depends on Spring Core, who depends on Snack YAML, who depends on Jackson JetBind, who depends on Jackson annotation, no? And this logging depends on other 2 sub-libraries. So it's not only the libraries that you have, you declare, oh, I'm gonna need logback and Spring Boot, but all the libraries that are automatically ingested with them. They all become part of your product. And in this case, oops, this has a vulnerability. And talking about the rest of the libraries, so all the transitive dependencies, so the one that you do not declare, but you get anyway. So this one has a vulnerability. And this is the one that we're going to basically exploit live after. No? So there is a vision for managers here. So this is your sample project. And you have logback that has a transitive dependencies, SL4J. Then you have Spring Boot, Spring Core, Snack YAML, Jackson. Ta-da! This has a vulnerability, and this one has 4. So there's a 4 different way to exploit Jackson data bind 288, as we know so far. It could be worse, but so far. I would probably use JSON if it was you, but whatever. Now, let's have if you want, I can have a look. Actually, what's interesting is having a look at what is a vulnerability. So I show you here some common libraries. Who's using Vertex? I do use it. Vertex? Nobody? Come on, it's cool. You're not using Vertex? It's like Node.js for Java. It's amazing. Everything is asynchronous. It's magical. You should use it. Well, not this version, though. Wait for the next one. But it's amazing. Struts, we saw it. And Spring Boot, we saw it. So what I can see, what I can show you here, if I am able to move the browser on that screen, wait a second, is what we have here is the inspection of Vertex that this is the tool that I'm talking about that we are building. And basically, we have few vulnerabilities in Vertex. No? Oops. No. Which is interesting. So those are all vulnerabilities that can be exploited. In the current, latest production version of Vertex are there. I can exploit them. You can probably exploit it after this task, after this talk. You will be able to do it. Okay? And this is Struts. This is Struts 2.5.16, which was the latest at the time, like a month ago. I don't know if they did anything, but this is the situation that they have. 1, 2, 3, and a lot of dependencies that need to be updated. No? And then we can have a look at Spring Boot. This is not the latest version. This is November 2017. So in a coding world, it's like 20,000 years ago. But still, I had it. No? And this has also an interesting set of vulnerabilities. 1, 2, 3, 4. Again, Jackson data bind is everywhere. Also one on Hibernate, why not? No? So we have to be very aware of these things. So we're not talking about something that is not there. It is there. It is there. And you have to face it. And you have to do hard choices sometimes. So choose, instead of library A, library B. Or if you use library B, be very aware of the vulnerabilities and make very, very, very sure that you're using the latest version. And if it has any vulnerabilities, triple check that you're not, exposing them. And you can read the documentation, and you can access the CVE and see what they are. But yeah, anyway. Now, what we're going to do in the next 10 minutes is the demo. Oops, no, sorry, too fast. Is the demo. So we're going to exploit this particular vulnerability, CVE 2017-7525, which is the Jackson data bind vulnerability. Is present in a lot of Jackson data bind version. I'm using here a slightly old vector that has been patched in the latest version of Jackson data bind. However, there are new vectors that you can use. I'm not going to tell you, sorry, but you can find them on the internet. There are new vectors that you can use, and they're not yet fixed. So the starting will be Jackson data bind, of course, and your server. And on the other side, as a supporting actors, we will have JSON deserialization Xalan. Because Xalan is the one that we're going to use as a vector to inject the vulnerability in our system. So let's pause this for a second, and let's go, well, I can go this here. So it's going to be a little bit difficult because it's down there and my eyes are gone. So, but I will try to explain you what I see there. So basically, this is our system. So I'm using here a library called Spark Java. And Spark Java is very nice. It's like Sinatra for Java. It allows you to basically declare your server. You say, OK, this is a server running, HTTP server running on 888. We have a products endpoint that returns a collection of products. And then you have a post that allows you to add a new product. So this is just very easy stuff. So you can see here, you get a collection. We have a product subject, which is products is the database of all products. We're going to see it later. And, it just serializes it back using the serializer, which is an object mapper for Jackson database. We have one serializer and one deserializer, two object mappers from Jackson database. And this products is the product database. So this is the list. And this is the call that allows you to add one product. So basically, you deserialize the request, no? And then you see, OK, is the product good? If it's not null, then I add it. Otherwise, I return 400. And the deserialize is nothing incredible. It's here. So it's just doing deserializer.read value. I'm passing the request body and the product class so that the deserializer knows how to deserialize the JSON into a product Java object. OK? So we're sending JSON. The JSON arrives, get transformed into the Java object, deserializing a Java object, and then it is being added to the product. OK? All good so far? Yes? OK, cool. Now, you can see, the product database is incredibly complex. It's an hash map. I initialize it with some product, no? Apple, orange, kiwi, all from Italy, because you have to know that in UK, they have these things that they call fruit, but it's not really fruit. So you get an apple, it's like this, like big like this, and you can leave it outside, and it lives for 2 months. And then suddenly, 2 months and 1 day, it decays, like this. That's the fruit in UK, OK? All due respect. Your fruit is very bad, guys. Horrible. Italian. So I put only fruit from Italy in my database. So the list is just to return an unmodifiable collection of the map values. There's a find by ID that I don't use. I don't know what I added. There's an add product here. Just add the thing. Oops. Add the product to the list, assigning it an ID, and then there's an update that I probably don't use it. I don't remember, but the problem is not here anyway. And then the product thingy. I have the product class here. The product class is just is a value object. It's not final because I had to do the protected constructor for Jackson database. I was too lazy to create the JSON annotation. The thing that is going to hunt you is this one. So here's the generic data. Because we don't know really what we want to put in it. So we're going to put the data object, and then we can put a map, or we can put whatever. And JSON, we serialize it easily. That's where the problem happened. Because in that field, I can put anything I want, potentially. And how do I do it? Well, we're going to see it. But first, let's have a look at our database in action, how powerful it is. Oh, sorry, our server in action. So here, it's completely blocked. OK, here we go. Sorry, I have some problem controlling the. OK. So this is started. So this is the server started listening on 888. And then here, I can do. OK, I have a set of curls here. So I can do, well, we can do list. So this will execute a curl, all right? Just a standard HTTP curl. You don't see all of it, unfortunately. But OK. So this is just a simple curl that goes on the server. You see the server receives the message, no? and it returns the list, and here you show the list. So simple HTTP call, get against products. And then I have another product. If I find it, well. Here we go. That creates a new product. So I just create a new product. I can see here, so that has been called. So here, products add. I added a melon from Italy, of course, and that is in the database now. If I go back and I get the list again, I will get also the melon. So the melon is the last one. Okay, all good. So the way we exploit this vulnerability is sending in the JSON content serialized Java bytecode. So what we're going to do, we're going to create our exploit class, extending from another class, and encode it in base64, and then put it in the JSON payload. So that class will be then deserialized by the Jackson based on our instruction, because we're going to tell Jackson, deserialize this class. I'm going to tell you it's this kind of class. So Jackson will deserialize it, create the class. When the class is created, it will run the constructor, and our exploit will be executed. So let me drive to the code quickly. Right, now, the exploit is, oh my God, I don't see anything. Oh my God, sorry for that. So this is a JSON exploit. Let's have a look at it. So as you can see, so all the fields are matching the products field, but the last field, data, is the one that we're gonna look into that. So that field tells Jackson, okay, please deserialize this as a templates impl. So when Jackson finds the data object, it looks at the type that we put there, and it will create a templates impl. And what the heck is the templates impl? Well, templates impl is a class of Xalan. It's a class used to read bytecode from XML files. So, and has these three interesting fields. One of them is extremely interesting, which is called translate bytecodes. So when Jackson creates the template impl, then it will start putting the value that we declare for that class. And one of that value will be translate bytecodes. So it will create the template impl, put the translate bytecodes in it, put the translate name, and then it will try in the output properties to put them. But before put them, we have to read them. So the moment it tries to read them, the constructor will be executed, and that bytecodes there will be, at that time, real Java code. So how do we do that? So we have this exploit class. Yeah, sorry, it's a big. It prints this at the moment, -10, yeah. And it's just, you see, our exploit extends abstract translate, and basically does nothing, just print the string. But the good thing about that is that we can encode it. So we can encode it in bytecode. So here, this is the encoded bytecode. This encoder is in the GitHub project. So you encode your exploit in binx. You copy the binx in the exploit JSON, right? If I found it, and then you can do this. Oh. So I can. So remember, this is the client, that's the server. The server is running elsewhere in your network behind the tons of firewall. So you have a firewall, then load balancer, then firewall, then load balancer, then firewall, load balancers, and then finally your server's down there in the restricted, super secure area. And I'm sending a JSON file, a JSON message, all through that via nice HTTPS, secure, go all down there, and reach your server. And when you reach your server, oops, nothing happens. Let me go there. Here we go. Actually, it's get executed. I don't know why the screen doesn't refresh here. So that's what happens. So I just sent a JSON message from here, gets transformed into a class, and gets executed. I can put anything there. So if this was working, if this connection was working slightly better, I can do, I don't know, I can do like, I can copy, I can change this. I can do this, and do this. And I can do welcome to Codemotion. Okay. The claps are telling me that I'm late. Here we go. Save. So I do this, I encode it, I change the class, compiled, encoded. Okay, copy this in the JSON file. Sorry. Okay. Here we go. Put it there. I'm just doing live. I changed the exploit to, because then you can say, oh, it was all fake. No, it's true. Here we go. Save. Then go back to the client. Here we go. And come on. Demo effect. Oh, come on. Sorry, just the screen doesn't refresh. It's so annoying. Put it here. Sorry, I cannot. I don't know what's happening with the screen, but it doesn't refresh. I don't know why. Sorry about that. But you can try it at your. I don't know, I just messed up. I don't know what's happening with the terminal, but you can try it at home and it will work exactly as I told you. So change the exploit class, compile it, and it will rerun again. Now, let's go back to the presentation. You have just 5 minutes now. Nope, not this one. So what are the preventive measures that you can put in place? So what you need to do is integrate a scan in your CI/CD, and there are good tools that are able to do that. There are open source tools that are doing exactly that. So you can put it in your pipeline, run it locally on your command line. It will be check if you have any vulnerability in your code. Checking the libraries and the dependencies. So basically, they will compile our code, compile the list of dependencies, check against the database if any of those dependencies has a problem, and then we'll tell you, well, you may need to upgrade this or that, okay? And there are big commercial powerhouses like Black Duck Software, small commercial solutions like BitHound, Akiri, Meterian, the SAS, and open source option like Dependency Check, and even GitHub started doing that. So now, if you commit to GitHub, there's a strong possibility that GitHub can tell you, oh, you know what? You're actually committing a vulnerable library. You may not want to do that. So it's very important that you have one of these tools in your pipeline that checks if any vulnerability is present, okay? Now, there are the usual things that I get told by people, which might be some of your question. So my code is not using that function. I know there's a vulnerability, but my code is not using that function. Well, usually you have, it's not only you have a big team working for you, right? And maybe not you, maybe not today, but tomorrow somebody can start using that function. And at that point, you have to have something that tells you, ooh, stop. Better doing it before. There's no reason to not keep your libraries updated, really. Yeah. So I'm shielded by my input validation. I'm perfectly safe. That's big, incredibly big BS, because that JSON was perfectly fine. And yes, you can create some form of validation to detect, for example, in that specific case, to blacklist some class to be deserialized, like, for example, Jackson Databind is doing. Jackson Databind is doing exactly that. And because they find new classes, new exploits every time, they keep blacklisting, and release a new version. Then they blacklist Xalan, new version. Then they blacklist C3PO, new version. Then they blacklist new version. It's just crazy. That's not the right approach. It won't work. And yeah, penetration test will not help you. Usually, penetration test companies are not able to do this kind of deep, specific, insightful attacks. They're not doing that. There are few now that are starting doing that, but the normal market is not catering for that. So it will not save you. And also, you know, when you do a penetration test, you do once a year, once every 6 months, costs a lot of money. So you want to have something cheap that runs continuously. So my conclusion is, as every project uses open source libraries, and exploits are very common for such libraries, and they are exploitable. So now the code that I gave you, you can do it yourself. It's on GitHub. The only solution is to put in place a mechanism in your pipeline that stops that, okay? That will continuously check your software and make sure that it doesn't use vulnerable libraries. And I suggest you to do it now. So here, in my last slide, those are the public databases of vulnerabilities. This is the code I use today. You can check it out and run it yourself, and I assure you will be able to change the code and do whatever you want, even wipe the entire disk. Don't do that. This is the dependency check tool. It's an open source tool that you can use to do these things. You put it in the pipeline, and it does exactly what I explained you. So it constantly checks any vulnerable library. It will tell you have to upgrade it. And then, of course, that's my plug. I'm running this. So we have our tool, which, of course, is better, of course. It's even also better colors and everything, you know. And yeah, I mean, just make sure that you use any of those, OK? And then, of course, if you can tweet and, you know, and put a nice green stack at the end, that'll be great. And if you have any question, now we don't have time, right? Do we have time?
Yeah, we can take 2 or 3 questions.
2 or 3 questions if you have them. So I have to wear my thing. Wait a second. I have to wear my headphones here. Oh, my God. That's so weird. Hello, hello. OK. Yeah. That's weird. I can hear myself. Amazing. Any question? Come on. I just better. OK, good. Good. Because I just dressed like this, like an idiot.
Yeah, you showed a field of object.
Yeah.
Is that really used out in the field?
Well,
I mean, I've never done it.
It's called polymorphic. Hello. Okay. It's called polymorphic transformation, and yes, it's used. Not in that naive format, but in other formats, yes, it is used. And you can. I cannot tell you, but you may be surprised sometimes. Open some people code and see what they do. All right. I mean, just do some more code reviews. I know you're probably doing a lot of them, but you will see why you're doing that. It's full of that. Full. Yes. Good. We have another question. Great.
Well, for non-Java developers,
Yes.
I'm just wondering if this is equal to eval in other languages, because it looks like one, which you should never, ever do.
Well, deserialization is super common. So in Java, it's used everywhere. And it's used, so this is deserializing a JSON message. But it's also very common to deserialize binary data. For example, BEA WebLogic, a very common, very well-used application server, uses the T3 protocol, and the T3 protocol uses Java serialization, and that's how one of the exploits was done. One of those 3, I don't remember which one, basically exploiting that. So injecting crafted binaries inside that. So serializing and deserializing content is extremely, extremely common. More than you think, a lot. I mean, it's everywhere. Whenever you have a REST API that receives a JSON message, then you have a deserialization and serialization happening there. So, and also happening in Node.js, in I mean, Node.js has a complete different set of vulnerabilities, but there are a lot of, for example, just quoting one, there are a lot of them also there. Same problems, very similar to these. Yes. Those things are really happening, guys. I mean, I know you cannot believe it, but they're really happening. Yes.
I was wondering, what do you do when there's a CV vulnerability, but the library has not been patched?
Well,
Like these.
like like these poor guys. Well, it's nothing. Well, if the library, sorry, I cannot hear very well from here, but I understand your question. So, if the library has not been patched, the only way you can do it is do a lot of checks on your side. So the first thing that you need to know is be aware of it, because most of the times you don't know. So for a while, Jackson data bind was used in Spring, which is used in Spring Boot, was not patched. So whenever you were using Spring Boot, you were also obtaining Jackson data bind for free, and that version as a transitive dependency, and that version has that deserialization problem. So what you can do? Well, you can select a different library. You can say, okay, dear Spring Boot, I'm going to use JSON, Google JSON, forget Jackson data bind. Or you can be aware of the vulnerability and whitelisted, blacklisted yourself. But that goes down to your ability to fix it. And but the basic things that you need to be aware. So you need to have a tool that alerts you of the problem. And so most of the times, 90% of the time, the fix is there. But 10% of the time, you will have maybe to switch the library or do some form of hack yourself. Okay? Make sense? Kind of. All right. Cool? Well, thanks for being here. It was amazing to see such a big room, and I hope you see something of interest today. Check my code, try it. Way to go. Thank you.